Hello, my name is Nicoleta. Welcome to this online seminar of our series about silicone surfactants. We have prepared this chapter with the Technical Department of Concentrol, in particular with Dr. Lopez, to take a deeper look on silicone additives specifically directed for high resilience polyurethane foams. High resilience, or just HR, flexible PU foam silicone surfactants are additives that are required to perform two functions. On the one hand, the stabilization in the foaming process. On the other hand, the regulation of the size and the distribution of the cells originated in the process of the mixture of polyol and isocyanate. HR formulations have different needs for cell stabilization and regulatory efficiency, as we can find TDA systems, MDI systems, or mixtures of both. This is why, as a first requirement, we need to offer a wide range of additives to meet all these possible needs. In addition, as another requirement, as these systems are usually quite stable, what is really sought after is a well-balanced form openness. Furthermore, due to the increasingly demanding requirements of legislation in the automotive and mattress industry, what is required is a minimum contribution of emissions of volatile organic compounds, or also known as VOCs. Emissions are classified into VOCs, volatile organic compounds, and fogging organic compounds. VOCs, which include VVOCs, very volatile organic compounds, and VOCs, are easily released from a PU foam in a closed car in summer, when the temperatures are between 25 and 90 Celsius degrees can be reached. Fogs are the sum of VOCs and SVOCs, semi-volatile organic compounds, that evaporate at temperature above 90 degrees. However, in a polyurethane formulation, the percentage of surfactant within the formulation is very small compared to the others, and their contribution is small. In this way, it facilitates the requirement we have just explained about the VOCs. For the determination of VOCs and fogs in a car interior materials, the most widely used methodology in Europe is FDA 278. The FDA, or Verband der Automobilindustrie in German, is the German quality management system for the automotive industry. It is the standard method in Europe that uses a method of gas chromatography by thermal desorption mass spectrometry. The FDA 278 method determines the emissions of non-metallic materials used for interior parts in motor vehicles, and includes determination of both types of emissions in two analysis steps of the same sample. In this application, the focus is determination of volatile organic compounds for polymeric materials by thermal desorption of sample, followed by separation and a chromatographic detection of gas with a mass spectrometer. For the VOC analysis, the sample is kept at 90 degrees for 30 minutes, and for the fog analysis, the sample is kept at 120 degrees for 90 minutes. However, the results obtained from this methodology are from all the VOCs and fogs that the polyurethane foam has. Within these results, we must look for those volatile components that are produced by the surfactant. It should be noted that in other markets, such as the Asian market, other methodologies are used for the analysis of VOCs. In addition, in this same market, the minimum contribution of aldehyde and aromatic compounds is also sought. The VOCs and fog from the silicone surfactant are usually cyclic and linear units of low molecular weight polysiloxanes, which we can analyze by GCMC chromatography. In the following table, the value found by the GCMS chromatography technique can be compared with the value determined by the FDA 278. In the shown examples, we can see that the value of the chromatography, that is, the maximum VOCs quantity, is always greater than the actual value found with the VDA 278. Here, you can see the values for the references specifically designed for MDI PU systems. And the following ones are the values of the surfactants for MDA and TDI mixtures, and in the last place only TDI systems. Given these requirements regarding the emissions, in the last years it has been investigated how to reduce the VOCs, FOC, and aldehydes of silicone surfactants with a new generation of products that allows the obtaining of polyurethane fumes with emission values related to the stabilizing below 20 parts per million for a dose of 1 part per 100 parts. Similarly, in recent years there has been a ton of compounds, the phthalates, which are frowned up and persecuted. This has led to the elimination of some of these compounds in the formulations of silicone surfactants. However, not all phthalates are banned, and some surfactants still carry these types of products. Moreover, in some markets there is another requirement, the low odor. The odor is attributed mainly to aldehyde compounds. For all these reasons, currently there are 3 types of products within the STB-PU12XX range of concentrol, although there are no performance difference between them in the polyurethane foam. STB-PU12XX is the first line design that carries phthalate compounds. STB-PU12XX-PF is the second line designed free of phthalates but high in aldehydes and aromatics, more directed to the European market. And in last place, the STB-PU12XX-PFJ is the third line design free of phthalates with low content of aldehydes and aromatics, aimed more at the Asian market. So, in this table, we can see the range of surfactants for HRPU foam. In the first half of the table, we find medium and low stabilizing surfactants. They are products aimed at the MDI formulations and some of them to work as a co-surfactant in systems with TDI. Currently, the startup products are 1231, 1234 and 1235. On the other hand, in the second half of the table, we find the medium-high stabilizing surfactants. They are products aimed more at the TDI formulations. Currently, the standard product is 1259. This last reference, the 1259, is one of our star products. It is a surfactant used in blocks co-cured mode polyurethane foams and formulations with polymer polyols, PIPA, PhD or SAN to achieve some foam hardness. It works very well especially in TDI systems or in TDI and MDI systems with an excellent balance of cellular regularization and with great stabilizing effect. It provides an open cell, easy to crush foam, also in unstable formulations with high water and solid content. In MDI systems, it can also work in low doses, less than 0.5%, and with the help of a cell regulator such as, for example, 1234. It improves the surface stabilization in difficult or low-filled parts of the foam. In addition to the wide range of uses in applications, this new technology surfactant also has advantages such as that is non-hydrolyzable. The PF and PFJ families are free of phthalates and they have a very low contribution of VOCs emissions. It should be noted that it offers optimal stabilization and very wide processing latitude. The usual doses vary depending on the system. In MDI is required a small amount, below 0.5, with the help of a co-surfactant, and in TDI or TDI-MDI mixes systems a higher amount, from 0.5 to 1.5 parts. However, in other markets such as Asia, not only low VOCs emissions but also low odor, aromatic and aldehydes compounds are required. In the current table, you can see the aromatic compounds that are not desirable to have in the formulations of our products. In this table are presented the volatile compounds of carbonyl type, that means aldehydes, and these are the ones that are being tried to avoid. Once explained this, we have to say that the old generation family, the first line, meets good values of aromatics and aldehydes. However, it contains phthalates, and it is a problem due to the OM requirements, as we have already explained. For this reason, the new PFJ family was designed to meet all the requirements of free phthalates and low aldehyde and aromatic contents. In the table, you can see that the content of aldehydes and aromatics in the PDF family is much higher compared to the content provided by the new PFJ range. This table shows some other examples of surfactants from the new PFJ family, in comparison to a standard product according to specific methodology, the Hyundai MS355. You can observe that the amounts of aromatics and aldehydes in the PFJ products is low. And to finish, in this last analysis, other compounds were evaluated in the same surfactants. The low aromatic and aldehyde contents can also be seen here. In this case, these are more odor-related compounds. Finally, Concentrol has been doing an important studies and R&D work regarding this range of silicone additives. Some of the technical work that is being studied is about the relationship between silicone surfactants and emissions, particularly under FDA 278 method, and it was presented at the PSE Europe. Later, the technical paper about this study was published at the PU Magazine International, and after that, a second study about the evolution of this R&D work was published again. Finally, mention that webinars and presentations in important conferences are held to talk more in depth about these types of products. You can download the webinar from our webpage on the part of updates and media. Here ends our technical presentation about silicone surfactants specifically designed for HR molded polyurethane foam. There is an episode for each type of polyurethane foam. You can look for the one that you are interested in. Thank you for your attention and see you soon again.